All right, let's take another example. Let's suppose I want to find the longest word in the dictionary file, which is on my machine here, standard Mac location for the dictionary file, Unix style, is in user share dict words. So our job is to find the longest word in this file. So what's the type of longest going to be? It's an IO string. It's something which is going to interact with the operating system in order to read this file and produce a string as a result. So the type of this thing will be IO string, and it's something which we could use in other programs of type IO. But we couldn't use it in a program which didn't have an IO anywhere. We couldn't hide the fact that this function has interacted with the outside world. So what is the longest going to do? Well, you notice here I'm starting on the next line. It doesn't matter where I start. The main thing is that all the lines in a do expression have to be aligned in the same column. That's our brackets, right? Aligning in the same column. So that can be a source of tricky bugs. Another source of tricky bugs is if your editor, your text editor, uses tabs. Your text editor shouldn't use tabs. It should only use spaces. Because a tab may have a visible appearance of, say, 4 spaces, but actually only counts as 1 character. So when you think that something is lined up, it's actually not lined up. It's just that your editor is displaying a tab as a wide thing and not as a single character. Okay, so that's a little warning that some of you have probably already been bitten by. So I apologize if that warning is later than it should have been. Okay, back to the longest. Obviously, we're going to read file, and we're going to read this thing here. And if we're going to do anything interesting with it, we better give it a name. So that's the word list that we're going to get from performing that operation. What are we going to do with that word list? So word list now is a string, but of course it's inside a do, so we're never going to escape IO. We need to find the longest word. So let's do that computation as a pure functional computation. Finding the longest word in a big string, we'll treat that as separate. So what we want to do now is give a result of computing the longest, let's call it long, and make a local definition. So long, we'll take a string and compute the string, the longest word in that as a substring of that string. Let's just make it undefined for the moment. Okay. So now my do block gets the contents of the word list and then is computing with some function we've not yet defined the longest word. So let's compile that, and we see we have a problem. We couldn't match the expected type of IO string with the actual type of string. What we have here, according to our declared type, is that this thing should be of type string, but what you expect, the last command of a do block should have the same type as the whole do block. So if we want the whole do block to have this type, the last command should also have this type. So we have something of type string, and what we need is something of type IO of string. So we need a way of taking a thing and turning it into an IO of thing. Okay? Now I said we couldn't go the other way around. Can we go this way around? Well, the answer is yes, we certainly can, and there's a very small function, but a very useful one, for doing that. It's called return. So return, in this context, will take a thing, in this case a string, and turn it into an IO of string. So this is a trivial, return is a trivial computation. It produces a value without doing any computation at all. Okay, so that's one of the most basic computations. So if I return 42, the type of that is IO of, let's say, int, and it produces, it's an instruction for producing a number without doing any work at all, but it's still an instruction. Question?
Can you show us the type of return?
I can show you the type of return, but it will be a little bit more general than you would expect. So I'd like you to think of return as having the type A to IO of A. In fact, it's more general than that. This M here, we're using it when M is IO. So we're doing something which has an A to an IO of A. Okay, so what this is actually revealing is that everything we're doing today with do and returns and do blocks and all this other stuff is actually much more general than I/O. You can think of it as I/O is not the only kind of instructions out there. You can build your own instructions of your own types. But today we're dealing only with instructions for interacting with the operating system. But in fact, these are things which have much more general types. There's a class called monad, and I/O is one of the things in the class monad. Okay, that's how we would compute the longest. Of course, we actually need a function to define how to compute the longest word in a list. So we have our string, and we need to break it into words, and then we need to find the longest word. So you might think, well, maybe maximum would do that. So you remember words, I guess. It takes something like A, B, or it might be new line characters, C, and splits it into its words. In other words, splits it at every space or new line or tab or whatever character. So words will give us our list of words, and then we want to take the maximum. Now, is maximum the function that we want? What is the maximum of oh, what am I doing here? What is the maximum of AA, well, let me say A, BB. If we take the maximum of that, that looked all right, didn't it? What if we did AAA? So clearly maximum is not doing the right thing here. What is maximum actually computing here for our strings? Yeah, it's producing the last string in the lexicographic order. It's the last string in the dictionary order. That's what you would expect max to do. So that's not what we want. What we want is to compute one of the longest strings. Okay, so what's a good strategy for computing that? That's an interesting strategy. So you map, the suggestion was we do something like map length on to, well, let's take what we had before, which was words of that. We map length, we get a list of the lengths, and we can take the maximum of that. We could take the maximum of that. Would that give us the answer we want? Well, no, we actually want the word that has length 4, not the length of the longest word. So that will give us the length of the longest word. Here's an idea that works using the fact that this maximum function is polymorphic. It takes anything which is ordered, a list of anything which is ordered, and gives you the biggest. So what things are ordered? Well, loads of things are ordered. If you build a list of ordered things, they become ordered. Char is ordered, that's why string is ordered. Another example is if we take a pair of things which are ordered, the result will also be ordered. So what we could do is, instead of mapping length, we actually can build pairs of things. If we actually pair length together with the word itself, so we actually make a function out of this, it takes a word and gives you the length of the word and the word itself. Okay? And we see that what that's going to do. This is going to produce a list of pairs with the length followed by the word itself. Then when we look for the maximum, the length will be like the first letter of the word, as it were. The length will be the main thing we'll sort on. And so then you see that we have a length 4 word with 4 A's. So how do we get the result we want from that? We just need to take the second element of the function second, which takes the second element of a pair. So I'm doing this sequence of computations, and we get the maximum. So what is that sequence of things? Well, that sequence is just a composition of a bunch of functions. We paste that up there. We don't need the S here. We can just do it by composing this as a sequence of functions. We compute the words of the string, turn them into a list of pairs with length followed by the string, find the maximum of those, which will give the alphabetically first longest word in the sequence, and we extract that from the pair by doing second. Does that compile? It compiles. Are you excited to find out what the longest word is? The longest word is, it's pretty big, thyroparathyroidectomies. I hope you don't have to have one of those. Sounds like some nasty operation involving your throat. Interesting. All right. Any questions?
So So the do block kind of separates the pure world from the impure.
That's a good question. So the question was, the statement was that the do block separates the pure from the impure world. And the answer to that is actually no. It requires good programming to separate the pure from the impure world. So there's nothing to stop us from piling all this pure computation inside the do block. But it's good programming style to keep them as separate as possible. Why might that be? Well, one reason is that it's much, much easier to do testing in a pure world. We can use our nice tools like Quick Check, for example, to do automatic testing. It's much harder to test when we have interactive programs. So if you can separate your code into pure functional code, which doesn't deal with any I/O, and a small part of I/O, which kind of is the shell which just interacts, that interfaces to the outside world, then your code becomes much easier to test. But that doesn't happen automatically. That requires programming discipline and good programming style.